Hi, my name is Masood. I'm providing this training video for UOIT students to help them for a better circuit implementation in electronic labs. We are going to use our advanced breadboards PB505, but the techniques that we are going to introduce here is pretty much the same for any other sort of breadboards. So our advanced breadboard has 4 independent breadboards that could be used separately. Let's just stick to one of the breadboards. For example, this breadboard, the second one from top bottom. So we want to find out how breadboard is going to ease our life in population of a circuit. The fact that breadboard is there to avoid as much wire as possible by just using the connected holes together so that we don't have to connect them through the wires. So then we got to find out how the holes are connected together. So the holes in the middle are connected in the column. So vertical columns are connected. The holes on the side, so these holes, and these holes, and these holes, which are the two sides of the breadboards, they are connected horizontally. But then we have this rule that if there is a huge gap, it means that there is a disconnection. For example, the holes in this vertical column, they're all connected. So 1, 2, 3, 4, 5 holes are connected. But then because there is a gap here, these holes on the lower column are not connected to the holes in the upper column. But still the holes in the lower column are connected together. But this column is not connected to the next column. So columns are separated from each other. When it comes to the rows, these holes all here on this row are connected. But then we see this big gap here. This big gap means that this hole on the right is disconnected from the holes on the left row. So this is the way that we use to find out how holes are connected and how we can use breadboard to ease the operation of the circuit. So let's start with implementing a circuit. In this circuit on the paper, we have 3 loops that are connected together, and it's supplied by a 10-volt power supply. So the rule, not the rule, actually the professional way of doing it is to follow the topology of the circuit. So if you see a resistor which is horizontal, same as this, R1, R3, and R4, then you use it and you implement it in a horizontal way. If you see a resistor which is vertical, try to implement it on the breadboard in a vertical way. The reason is that when you look at the circuit for troubleshooting, you can simply compare it to your circuit, and the topology is going to tell you if you have implemented right or wrong. So you don't have to one by one find out if R1 was connected to R2 or R3. This is very important in troubleshooting, so always follow the structure of the circuit, the diagram, and select the same topology for implementation. So what I'm going to do, I'm going to start from R1, but does it matter? It really doesn't matter. You can start from anything. So I start from R1. It's a horizontal resistor. So I'll just put it on the breadboard in a horizontal way. So this is a horizontal way. Of course, I have to pick 2 different holes which are not connected. And I know the holes in this column are connected together, but holes on this column are not connected to the holes in this column. So both pins of the resistor are not connected together. So make sure you do that right. If you do it like this, this is wrong. Why? Because you have put both pins in a connected column. So this means you are shorting the resistor. So make sure that you don't do that. So again, I'm going to put a horizontal resistor. Then R3 is connected to R1, again is another resistor, so, and they are sharing one connection. So, and R3 is after R1. So let's first share the connection. So I have to insert one pin exactly in the same column where the holes are connected. This means that this pin is connected to this pin even though they are not touching, but they are in the same column with the connected holes. That's why they are connected. And the other pin is going another point, and again I make it horizontal. So you see I have two horizontal resistors right after each other. Okay, then I have to go to R4. So R4 from one side is connected to R1 at point A. So this is R4 which is connected to R1. So let's connect R1 from the top here. So it's connected. And the other side of R4 is connected to the free side of R3. So this is the side of R3 that we didn't connect before. So they go and they connect together. So you see I'm trying to keep the same topology. Two resistors horizontally connected on the bottom, and one resistor is connected to both of them on the top. Now it comes to 10 kilo ohm, the resistor R2, which is connected to the shared, so this B was shared connection between R1 and R2. Where was that? This is the shared connection. So one side goes here. Another side goes to the ground. So what I'm going to do, I'm going to pick one point as the ground. So what I am going to do, I'm going to use the property of this row where it has all the holes connected. So I'm going to connect this to this row, and I'm going to consider this as my ground. So this wire, the yellow wire, is considered as ground, and it's connected to this resistor. Why? Because all these holes are connected. So this and this are now connected. Now it's the time for R5. R5 from one side is connected to the shared point of R3 and R4, which is here. Because this was R3, this was R4, shared point is here. And then it goes to ground. We already considered this to be the ground. So I'm going to connect it to another hole on the ground. So you see that the topology is preserved. The last one is the power supply, 10 volt. So what I have here is my power supply, which is connected through the two cables. The red and black are connected to the power supply, and then the cables are coming here, and I have them ready to be connected to my circuit. So I'm going to connect the ground to the ground that I connected here, and the positive of 10 volt is connected to the shared point between R1 and R4, which is this point. So I'll just connect it to a red or whatever color that you choose, and I connect my positive cable coming from the power supply to here. So as you can see, we preserved the topology and structure of the diagram. So if there is any problem by comparing the horizontal, so I have two, for example, I have two resistors here in horizontal. If I look here and I see only one resistor, it means that I was wrong. Or I know that this two is like R4 is right above R1 and R3. So R4 is right above R1 and R3. So a simple comparison would tell me that if I made a mistake or if I didn't. The common problems that we normally see from the students in the lab is that they connect the resistors or any components in the same hole. Two pins are in the same hole which are connected. After you implement the circuit, just visually inspect your circuit and make sure there is no component. Again, the rule is that there is no component that has two pins in the same connected column or the same connected row. So always, if you follow that rule, you'll be okay, and your circuit and your troubleshooting would be much easier. So let's say I want to measure the current I3. The current I3 is the current passing through R4. So what I do, I have to use a multimeter cable, which is simply this cable. So I connect one side to volt. So this is my volt connection. I connect the other one to the common connection. So this is my common connection. And then what I have to do is to connect the other side of the cable, which is these two sides, in series with the resistors. So how would I do that? So what I do, I disconnect these 2 points from each other, and then I put like a current meter in the middle, an ammeter in here. So this is the way that I have to do. So a disconnection first, and then an insertion of a current meter in the middle. So how we implement it on the circuit is, so to disconnect this point from this point, I have to remove R4. So one side of R4 is disconnected, and now these two are the two disconnected points. And then is the insertion part that the current meter has to go between these two. So the cable from the meter goes between these two. I recommend that you always secure a point, not to leave any point like in the air. This point is already in the air. So the professional way is just to connect it somewhere on the breadboard, let's say here, and you got to make sure this point is not connected to anywhere, and then simply connect these two together. Now the current is going through the multimeter, and I can measure the current at R4. So always make sure that you connect the current meter in series. There are two steps: disconnection, so 2 points have to be disconnected, and then the insertion, which is the insertion of the cables from the multimeter right at the points that you disconnected. If you want to measure voltages, it's really easy. You don't have to disconnect any points from each other. You only connect. For example, in order to measure the voltage across R4, which is this resistor, I simply connect the multimeter in parallel with the resistor. So you can see that simply these two cables are measuring the voltage across the resistor. So to measure the voltage, you simply connect in parallel to the component. No disconnection is needed, as opposite to the current meter or measuring the current. So hope this video helped you to better implement the circuits. If you have any question, feel free just to send me an email, and I would be happy to answer your questions. Thanks for watching the video, and have a good day.